Hello everybody. So we have been on this topic of ultrasonic testing, and in last few lectures we have seen different aspects of this particular technique. And if you remember, in the last class I emphasized on the importance of calibrating the instrument before you do the test, and I have also shown you some of the standard blocks which are used for calibrating the instrument for ultrasonic testing. So, in today's class we will see what kind of blocks are used and how exactly the calibration is done. Okay. If you remember, I have also told you before that when you use a standard block for calibrating an instrument, you need to follow certain specifications, okay, in the sense that the block that you are using, it has to be made following some specifications, some particular dimensions and so on. Okay. So, in this case also we need to follow certain specifications, and as per those specifications these blocks are made, and we can use these blocks to calibrate the instrument. Okay. So, today in this class let us see what these blocks are, how these blocks are, and how they are used to do these two kinds of calibrations. As I told you before, one is distance calibration and another is area. So, these are known as distance amplitude calibration or distance amplitude correction and area amplitude calibrations. Okay. So, these are the two primary types of calibrations that you do for normal probes, and then I will show you later also, if you use an angle probe, then what kind of block you can use and how the calibration is done for the angle probes. Okay. So, today let us go ahead and see how this distance amplitude calibration and area amplitude calibrations are done. Okay. So, if you follow the specifications in this case, the block that you have, it looks like this. It is primarily a cylinder which has an artificial flow cut at the bottom in terms of a flat bottom hole. Okay. So, the defect or the artificial flaw that we are going to use in this case is a flat bottom hole, okay, which is cut at the bottom of the cylinder. Okay. So, this cylinder has to have a particular dimension as per the specification, and this flat bottom hole also has to have a particular dimension. Okay. Okay, so if you take a section of this cylinder at the bottom, so this is where you have this flat bottom hole, okay, and this will have a particular diameter and a particular depth, So, this is the depth of the hole, and the cylinder also will have a particular height and a particular diameter. Okay. For example, in most of the cases a diameter of 50 mm is used, and now using this kind of blocks you would be able to calibrate not only the distance, but the area also. Okay. So, when you calibrate distance, you need to vary the height of this block, keeping the size of the flat bottom hole same. So, if you, when you vary the height, then you could vary this metal distance, which is this one. So, in case of distance amplitude calibration, this metal distance is varied and the size of the hole is kept constant. On the other hand, when you calibrate the area, in that case the metal distance is kept constant and the size or the area of the hole is varied. Okay. So, this is how by varying the metal distance and varying the size of the hole, you can calibrate the distance and the area respectively. Okay. So, this hole is drilled precisely in the center of the bottom surface of the cylinder. Okay. So, you need to vary this metal distance, as I said, that means you need a number of these cylinders which will provide you different metal distances. That means you need a set in order to do the calibration. So, let us see what kind of sets are available that we can use and calibrate. So, there is a series called series B blocks, and in this case this is a set of 19 blocks. Okay. And this is how the cylinders are in this case. The blocks are diameter of the block is 15 mm. The flat bottom hole that you have, the size of that hole is it is 20 mm deep. So, that depth that I had shown you in the diagram, that is 20 mm, and the diameter of the hole is kept same in all the blocks, as I said, when you do the distance calibration. So, you can choose a diameter from this range and keep it constant. 1.22 and 3.2 millimeter. So, from this range you can choose the diameter. Okay. And in terms of inches, if you see these are written in terms of 1/64th of an inch, and why it is written in that fashion, I'll come to that. There is a reason behind that. So, the first one, which is 1.2 mm, it is 3/64th inch, The second one which is 2 mm, it is 5 by 64 inch, and the third one which is 3.2 mm, that is 8 by 64 inch. Okay. So, these are the three diameters that you have in this case. So, you select one of them and keep it constant, keep it fixed. Then you vary the metal distances, okay, because you are going to calibrate the distance. So, in these 19 blocks, these are the metal distances you have. You have 9 blocks with these metal distances 1.6 mm, 3.2 mm through all the way to 25 mm in increment of 3.2 mm. Okay. So, in this with these distances you have 9 blocks. In terms of inches, you have 1 by 16th of an inch, then from 3.2 mm to 25 mm, that is 1/8 of an inch to 1 inch, and then you have 10 other blocks with the metal distances of 32 mm to 150 mm in increment of 13 mm. Or half an inch. So, in terms of inches, this is 1/4 inch to 5¾ inches with an increment of half an inch. Okay. So, this is how this set is. So, using these different metal distances that you have, okay, you can have a broad range as you could see, and keeping that hole size constant, you can calibrate the distance. Okay. Now, let me come back to this and tell you why it is kept in this fashion, this hole diameter in terms of 1/64th of an inch. Okay. This is to give a nomenclature to these blocks, to give some kind of designation, so that you would be able to identify a particular block by a particular number. Okay. So, in order to create that number, in order to create that nomenclature, this kind of dimensions are given in terms of 1/64th of an inch. Okay. So, let me tell you how this is used to create that particular number through which you can identify a particular block. First of all, the number is like this, one number first, followed by a dash, and then 4 more numbers. So, this is the format, one number dash and then followed by 4 numbers. So, let us say you have a block which is given a number like this. Okay. as I am going to show you now, this is according to that 1 by 64th that we have given to the size of the holes. Okay. So, this first number that you have, the first digit is the diameter of the hole in terms of 64th of an inch. Okay. So, that means, if it is 3, then you immediately know that the diameter of the hole is 3 by 64 inches or 1.2 mm. Okay. And the last 4 digits that you have, these specify the metal distance. In inches. Okay. For example, in this case, these are the 4 digits. Okay. So, the metal distance in this case is 0.75 inch, that is 3/4 of an inch or 20 mm. Okay. So, these numbers are given first of all to identify a particular block, but through these numbers, as you saw it just now, you could also get the dimensions of the block both in terms of the size of the hole, okay, and in terms of the metal distance. And that is why, to get the size of the hole, we had written the size in terms of 1 by 64th of an inch. So, that the number itself will tell you 1, 2, 3 whatever it is, that it is 1/64th of an inch, like in this case the number is 3. So, the diameter of the hole, the flat bottom hole that you have is 3 by 64th of an inch. Okay. So, this is how the numbers are created and a number is given to each block. There is one more set, which is the ASTM blocks. And like the series B blocks, these ASTM blocks can also be used for calibrating both distance and area. So, this set of blocks consist of a 50 mm diameter cylinder and each of these 50 mm dia blocks will have a 20 mm deep flat bottom hole and then you can have different metal distances and different hole diameter in order to get either different distances for calibrating the distance or different areas for calibrating the area. Okay. So, this is primarily a set of 10 blocks which can be combined into different distances and different areas to calibrate either distance or area. And out of these 10 blocks, one block is like this. It has a 20 mm deep flat bottom hole with a diameter of 1.2 mm or 3 by 64 inches. And this one has a metal distance of 75 mm. or 3 inches. Then you have 7 blocks which are as follows. All the blocks have a 2 mm diameter hole and the metal distance is varied in this case. So, this will give you 7 different metal distances in these 7 blocks, and these are the metal distances: 3.2 mm, 6.4, 13, 20, 40, 75 and 150 mm. Okay. So, these are the 7 metal distances that these 7 blocks provide you, and there are 2 more blocks . One is having 3.2 mm diameter hole and a metal distance of 75 mm. Okay. And the second one is having the same hole, that is 3.2 mm diameter hole, but metal distance in that case in the second block is 150 mm. Okay, so this is how this 10 blocks that you have, it has a different combinations of metal distances and hole sizes also, and these blocks can therefore be used for both distance calibration as well as area calibration. Okay. Now, if you have an angle probe, then in that case these kind of cylindrical blocks cannot be used, because for an angle probe you need to calibrate the angle as well apart from the distances. Okay. So, when you have angle probe, the block which is used is known as IIW block, which stands for International Institute of Welding. So, this IIW block can calibrate both distance as well as angle. Okay. So, this is one block that we are going to take up separately, because we have to discuss in little more detail as to how exactly the angle is calibrated, but for the time being I just wanted to let you know that apart from those cylindrical blocks which are used for calibrating the distance and the area, you have another block which is primarily used for the angle probes to calibrate the angle, but this can also be used for calibrating the distance as well. And if you only want to calibrate the angle, then there are this kind of small blocks available just for the purpose of calibrating the angle only. So, this is a a small triangular block like this, which will have the angles graduated on the surface. Okay. So, on this face, for example, you could have this kind of angle scales, and with the help of this you would be able to read the angle of the beam which is coming out from the probe, from an angle probe. Similarly, on this surface also you would have these angle scales. So, depending on what is the angle that you have, either this surface and or this surface can be chosen when you are calibrating the transducer for the angle. Okay. Right. So, this is so these are the two types of blocks that you have available for calibrating the angle for a particular ultrasonic transducer. And as I said, this one we are going to take up separately later on, and we will see how this is used to first calibrate the angle. And as I am going to show you that time, this can also be used for getting some other information, particularly about some of the important parameters like resolution and things like that. This IIW block can also be used for that as well. Okay. So, for today this is all I will have. So, for today I will stop here. Thank you for your attention.